Algebra 2. This is section 751, which is simplifying complex numbers. And so by the end of this, you should be able to simplify complex numbers and complex radical expressions. So a long time ago, we told you that if you got a problem like the square root of -4 and you had to simplify it, that the answer was not a real number, and that you couldn't do it, and you couldn't take the square root of a negative number. And that was partly true. The thing is, though, you can simplify this, and the answer, well, it does have an answer, and the answer is not a real number. It is an imaginary number. Okay? The answer to that is an imaginary number. The answer to the square root of -4 is 2i. And this I right here, this little I, means imaginary. It's not a real 2, it's an imaginary 2, right? So it's not a 2i that you can graph or you can do much with, but it just kind of symbolizes something. And that's about all we can do with it, is just say, well, the square root of -4 is imaginary. Later on in this chapter, we'll add and subtract imaginary numbers, but other than that, we can't do too much beyond that. Well, we can multiply and divide them, but nothing like we can graph or anything crazy like that. We definitely can't solve word problems with them. Now, if you think back throughout your math career, there are a few letters that are never used for variables in your math textbooks. We never use E. E is actually, lowercase e is actually a number, and we're going to get to that in chapter 10. Lowercase e actually stands for something very important in the math world, and we never use lowercase I for a variable because it means imaginary, okay? So to give you a few examples of how this works, the square root of -4 is 2i, and the square root of -9 is 3i, and the square root of -16 is 4i, and so on and so forth, right? And I could keep going forever and ever and ever. So whenever you take the square root of a negative number, it's just the square root of that number, and then you attach I, okay? So nothing too complicated here. And then the other thing that I want to say, there are a few things in this that you should memorize. So you should memorize the fact that the square root of -1 is I, and you should memorize the fact that I squared is -1. Okay? These two things are going to come up again, and if you are very familiar with these, and you can work with them pretty easily, it'll make the rest of the problems in these next few sections pretty simple, okay? So the square root of -1 is I, and the square root of I squared is -1. Or I'm sorry, not the square root, but I squared is -1. Yeah, let me say that again. I squared is -1. Okay, so moving on from here, now we can also take the square root of things that aren't perfect squares, right? So let's say we have something like the square root of -12. Well, the square root of -12, okay, the first thing we always do when we take a square root is pull the I out. So your first step would be to rewrite this as I root 12, and then you could take 12 and break that down into 4 and 3. And then the square root of 4 is 2, so you can pull that out, and then you leave the 3 on the inside. Okay? So then your answer there is 2i root 3. So just like we can kind of work with square roots that aren't perfect squares, we can do the same thing with these square roots of negatives or imaginaries, and we just attach this I at the end. Another important thing to note, when we have these i's, we like to write them in front of the radical, because then it doesn't get confusing with what's inside the radical and not inside the radical. So definitely go ahead and write your i's in front of the radical. So we've talked about imaginary numbers. So imaginary numbers include I, and a complex number is, that has two parts. So a complex number is a real number plus an imaginary number. Okay, so a complex number is a real number plus an imaginary number. So an example might be something like 3 plus 2i, right? So 3 is real, and then 2i, because it has the I attached to it, is imaginary. And we could do another example. We could have subtraction in there. We could have 8 minus 10i. So you can have subtraction. So your real part is 8 and your imaginary part is 10i. And we could also have things with radicals. So we could do something like 4 plus 2i root 3, right? So even though this includes a radical, it's still imaginary, and you've got a real part, so the whole thing is complex together, okay? So now, so that's kind of a very basic introduction to imaginary numbers and complex numbers. So we'll go ahead and we'll do this classwork together. So for the classwork, for number 1, we have the square root of negative 49. So the first thing that we want to do is pull the I out, okay? Let's see, so I'll write my I on the outside. So then I have I root 49, and we can take the square root of 49, that's 7. So then your answer is just 7i, okay? For number 2, we have the square root of negative 8. So the first thing I want to do here is take my I out again. So I have I root 8, and we know 8 is not a perfect square, so we'll rewrite it as 4 times 2. And we can take the square root of 4 and pull that out. The square root of 4 is 2, so I'll have 2i root 2. And there's our answer there, and we're all done. For number 3, we have the square root of negative 12x squared. Okay, so again, first step is always, whenever you have a negative inside a square root, pull your I out. So I'll have I root 12x squared. So 12 is not a perfect square, so we'll rewrite that as 4 times 3, and then we'll have x squared. So the square root of 4 is 2, so we can pull that out in front. So I'll have the 2 out there. I'm going to have the I. I can't take the square root of 3, so I'll leave that on the inside. The square root of x squared is x, so we can pull that out. Okay? And so your answer is 2xi root 3. So these answers, if they've got variables in the problem, the answers can also include variables. For number 4, we have the square root of negative 200. So we pull our I out, so we have I root 200, right? Now 200 is not a perfect square, so we want to break this down into the largest perfect square we can. So 200 is the same thing as 100 times 2, and the square root of 100 is 10, so I'm going to have 10i root 2. Okay, so moving on. Let's see, let's take a look at, well, we skip over 5 and 6. Let's jump down to number 7. So for number 7, we have the square root of negative 108x. Okay, so we'll pull our I out and we'll have I root 108x. So we want the largest perfect square inside of 108. So let's see. Half of 108 is going to be 54, and then if we go backwards from 54, I'm looking at my list. Let's see, half of 108 is 54, so 54 would be right here. So 49 is not a factor of 108. 36, I think 36 is. 36 times 3, yeah, 36 is a factor of 108. So 108 is the same thing as 36 times 3, right? And the square root of 36 is 6, so we can pull that out. And then 3 and x, we can't do anything with those, so those will stay on the inside. So we have 6I root 3x, okay? Going on to number 8, we have the square root of negative 180y cubed, okay? So we can pull our I out, so we've got I root 180y cubed. So we've got to break down this 180. Well, 180, let's see, if we cut 180 in half, that turns into 90. And if we look at our chart, so 90 would be right about here, and if I go backwards, well, 81 is not a factor of 180. 64, no, 64 is not a factor of 180. 49 is not a factor of 180. 36, let me see, is 36, let's do 180 divided by 36. Ah, yeah, 36 times 5 is 180. Okay, so that'll work out well. So 180, we can break that into 36 times 5, and then we have our y cubed. Alright, so the square root of 36 is 6, so I'll pull the 6 out. We still have our I. We can't do anything with the 5, so we're going to leave that on the inside. Now, the square root of y cubed. So to do that square root, you would take that exponent of 3, right? So on the y, we have an exponent of 3, and if we're taking the square root, we're going to divide it by 2, and that would give us 1 remainder 1. So that means we would have 1y on the outside and 1y on the inside. So your answer, 6yi root 5y. Okay, so going on to number 9. For number 9, we have root 9a to the 6th plus the square root of negative 9a to the 6th. Okay, now the first one is not imaginary because we don't have any negatives on the inside. So this is really easy to simplify. Square root of 9 is just 3, and then the square root of a to the 6th is a cubed. Now, this one is imaginary, so we'll pull that I out. Okay, but these are also perfect squares. So square root of 9 is 3, square root of a to the 6th is a cubed. So let's go ahead and rewrite it with the I at the end. So we have 3a cubed plus 3a cubed I. And that's your answer to number 9. Alright, so going on to number 10, we're going to have the square root of 16 plus the square root of negative 25. So square root of 16 is 4, square root of negative 25, we pull our I out, and the square root of 25 is just 5. So your answer, 4 plus 5i. For number 11, we have the square root of 36 plus the square root of negative 16. So the square root of 36 is 6. And then for the square root of negative 16, we pull our I out, and the square root of 16 is 4, so we get 6 plus 4i. And the last problem, number 12. So for number 12, we're going to have the square root of 49x squared y to the 4th plus square root of negative 100 x to the 4th y squared. Okay, so everything here is a perfect square, so we can just roll right through this. So for this first radical, we'll have 7xy squared, so I just divided all of those exponents by 2. Now this next one has a negative on the inside, so then that means we'll be attaching an I to our answer. The square root of 100 is 10. Square root of x to the 4th is x squared, and the square root of y squared is just y. So we pull it all out, attach an I at the end, and we're all done. So that's the end of 751, and I hope you know enough to go ahead and try the homework on your own.